Hello, AFDA students, and welcome to our video lesson 12. This one's from equations to graphs, and we're going to be working today graphing some equations on a coordinate graph and describing their characteristics. Terminology today might hear tossed around as the word linear, input, output, something called standard form, and something referred to as a t-table. Now, let's take a look at some examples here. I'm going to scroll down. And we want to be able to complete the tables and write them as ordered pairs and then put them on the graph. And at this point, you guys have plotted points, so we'll write them as ordered pairs. You don't necessarily have to do that because the table of values that we have here organized, you can probably go from the table right to your graph if you wanted to. But these guys right here, these x values that you see, we're just going to put those into the equation up there. Notice that we have two variables in our equation. We have an x and a y. We have this equation form. And if you remember way back in algebra, possibly that your teacher told you that when you replace, the safe thing to do is that on your calculator, if you replace a letter with a number, to put that in parentheses. That's the safest thing to do if you're using your calculator. But I'm going to try to do them in my head here real quick. I'm going to do 2, not times x, times -3. That's -6 minus 1 is -7. I'm going to plug -2 in there. 2 times -2 is -4. Minus 1 is -5. If I put 0 in there, I just get -1 out. If I put 2 in there, you know 2 times 2 is 4 minus 1, and I get 3. And then 4, 2 times 4 is 8 minus 1 gives me 7 there. And again, if you wanted to organize these as ordered pairs, squeeze those in there, you could definitely do so. You could write 4, 7, 2, 3, 0, -1, sort of bunched up in here, -2, -5, and -3, -7. So from here or from your table, you could go ahead and plot these points if you wanted to. So let me quickly do that. -3 and -7, look like that point's going to go there. -2, -5, looks like it's approximately there. 0, -1 goes there. 2, 3 goes right there. And 4, 7 goes way up here. Okay? And it looks like, let me put that point there a little clearer. It looks like this guy would graph something similar there. So this would be called linear because it makes a line. That'd be called a linear graph. And we're going to connect and understand the relationship between this graph and what the equation is and parts of that equation. So let's do another one real quick. If we put in -2, when we square that, we get a +4. -1 squared is a +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Again, very quickly, if you wanted to write them as ordered pairs, you could do that. We may not do this a lot here. We'll just do it this last time. 1, 1, 0, 0, -1, 1, and -2, +4. So let me graph those. -2, +4. -1, 1, 0, 0, 1, 1, and 2, 4, looks like right here. Now, this guy is going to be a little different than what we just graphed. That might look familiar to you. A U-shaped graph from Algebra 1. It says, what did you notice about the graph that was different from the first? Well, it was U-shaped, if you will. Okay, it's not a line. And if you wanted to, you could put U-shaped graph. Okay? So go ahead and write those down for a second. Now, again, you don't have to have a fancy table like this. You could have something like a t-table and just talk about x's and y's. And you could put any values that you want to in there. So, like for this one here, I could put a 1 in there if I wanted to and do 2 times 1 and see what my y value is. And I could put a whole pile of numbers in there. And in fact, this graph represents all the ordered pairs that are a solution to that equation. This graph represents all the points that are a solution, any x and y combination that's a solution to that equation. So let's do a couple more. I'm going to go here on the right side of the screen. I'll clear this out. So let's take absolute value of this x. Absolute value of -4 is 4. -2 is 2. 0 is 0. 2 is 2. And 4 is 4. So let's plot these real quick. -4 and 4 is right up here. -2 and 2 is right about there. 0, 0 is here. 2, 2 is right there. And 4, 4 is right up there, I think. 1, 2, 3, 4. Now notice that this guy is a V-shaped graph. Let's look at this one. Put -4 in there, I think we get -7 out. Put -1 in there, we get -4. Put 0, we have -3. Put 1, we have -2. And if we put 5 in there, we get a +2. Let's graph these points here real quick. -4, 7 is way up here, I think. I can see that. -1, 4 is right up here. 0. Oh, I got -4, -7. I'm sorry, that's -7. Forget that right there, guys. -4, -7 is way down here. Sorry. -1, -4 is right there. 0, -3 is right there, I think. 1, -2 is right about there. And 5, 2 is right over there. That looks a little bit better. So now, when I graph that, that looks like, once again, that's going to be linear. Okay? We have 2 more to do and talk about those here in a second. Check out these last 2 that we have. This one's written in a little different form, isn't it? And notice what I did with the table here. I put a 0 right there for a y value, and I put a 0 for the x value. Sometimes when you see this form right here, which is called standard form, okay? And if you were introducing this, that's ax plus by equals c form, standard. Sometimes it's easy to generate 2 points just by plugging in a 0 for x or a 0 for y. But we can do it differently if we want to. If you wanted to, could you rewrite that equation? Could you subtract 2x from both sides and do a little bit of calculations? Of course you can. You know how to manipulate this. So you could subtract 2x from both sides and get y is equal to -2x plus 12. So that's a form having that variable all by itself on one side. So if you want to see me do that longhand, I definitely will. So let's plug in 5 in here. So if we plug in 5 for x, we get 10 there, plus 2 gives me the 12. If I plug in a 0 for y, it makes that guy disappear. 2 times what value is 12? Of course, you guys know that's 6. We plug in 0 for x. We know that that is 12 there. I don't know if that's going to fit on there, so I'll put a little star by that. How about if we put in 2 for x? What do we get out of there? I think we get an 8 for the y. 2 times 2 is 4, plus 8 is 12. We put in 4 in there. 2 times 4 is 8, plus 4 gives me the 12. So I'm just plugging those in. Let's graph them real quick. 5, 2. Hopefully I do a better job doing it this time. I have 6, 0, which is right about there. I have 0, 12, which is up there somewhere, not going to fit. How about 2, 8? Will that fit on my graph? I think that does. How about 4, 4? 4 and 4. So I think this guy, again, makes a linear graph. And again, if we wanted to fill in more points, we could just pick some x values and put those points in there. Now, let's do our last one right here. This is a tricky one, so make sure if you're using your calculator to put it in parentheses So we got the opposite of negative 2, which is 2, plus 5, we would get 7 there. Opposite of negative 1 is 1, plus 5 gives us a 6. 0 plus 5 just gives us 5. If we put 1 in there, we'd have negative 1 plus 5, which is 4. If we put 5 in there, that makes that negative 5 plus 5 gives us 0. Let's plot them up. Got negative 2, 7. Actually right there. Negative 1, 6, which is right there. 0, 5, which is right there. 1, 4, right there. And 5, 0, way over here. Again, these points are all sort of bunched together up here, but there's no points in here. So if you, again, wanted to make a quick little t-table over here and put in some x values of, let's say, 2 and 3 to see what those good, you're more than free to do that. You can generate infinite number of points. Again, this is linear. Both of these guys are linear. But bottom line here, folks, from these is that the numbers in the equations, they definitely matter. The characteristics of the equation definitely matter, and we'll be talking about those more coming up here. So equations make graphs, okay? And in this case, we have 2 variables, so we're going to graph it in 2 dimensions. Folks, thanks for watching. Hopefully you can take an equation and make a graph just by making a t-table or table of values, and we can talk about what those graphs looks like. Thank you.